most people just don't have enough experience to realize how big the oceans are, how much water there is, how far away from anything you can be, and how hard it is to find anything out there. The biggest technological problem up until the early 19th century was simply knowing where you were when you were at sea. Then the problem becomes knowing where other people are as well, and it remains really, really difficult.
Geolocalization is finding your position underwater and trying to navigate from one place to another one. One of the main challenges with underwater navigation and geolocalization is that GPS signals do not penetrate, do not go inside the water. What the current standard is using acoustics information, sonars, little sonar beacons that send signals, and you triangulate and you find your locations. The accuracy does not work very well. In a small area, it's okay, but you have to define that area where you want to send those beacons. Another way that this is being done is having a little submersible tethered to a vessel. This can maneuver a little bit around the ship, but it's kind of very limited. So if you want to have a freely moving vehicle, this is an incredibly challenging problem. The way we solve this problem is by developing specialized cameras and machine learning algorithms. And by combining, what they do is they actually figure out where is the sun location. So if you're kind of broadly thinking about it, you're scuba diving or you're just snorkeling underwater, everything looks blue to our eyes. But if you're able to see polarization of light, so think of your polarization sunglasses. If you had a little bit more sophisticated polarization sunglasses, you'll be able to see this polarization light, which is actually very colorful, so to speak, because we don't perceive polarization. And those polarization signatures underwater are changing throughout the day. They depend on the location where you are, depending on the sun. So if you are able to perceive them, record them, and do some math behind it, you can extrapolate where is the sun's location, and from there, with an accurate time and date, you know exactly where is your location.
The question essentially from the computer vision side is this. I have a picture of the sky from underwater. What I'd like to know is how high the sun is in the sky. If I know that, then if I know the speed with which the Earth turns and the shape of the Earth and the day of the year, I can tell where I am. The way we did that was to collect, I think at the end of the day, about 10 million images of the sun from underwater. Each of them is tagged with where it was taken and the elevation of the sun. And they are sequences. So the camera sits underwater and it sees the sun move across the sky. Pass those images into a learning system and essentially adjust the system until it gives the right answer. Once it's giving the right answer, you now take in new images, you pass them in and you ask, is it telling you where you are? And the answer is yes, it does, up to the order of about 100 kilometers, something of that sort, which is really pretty good if you're far away from land.
The disaster that happened with the submersible, you sort of started to ask yourself, why couldn't we find things faster? And it also tells you sort of what is the state of the art of what is the current best technology we have for search and rescue missions. Going very deep into the water is very challenging, but also finding things near the surface, the first 200, 300 meters where our technology works very well, can help during this search and rescue missions. So the way I kind of envision it is this technology will enable smaller robots or smaller autonomous robotic platforms. They can roam around the ocean surface, and by ocean surface I mean the first 200 meters where light penetrates into the water, helps us uncover new phenomena, but also helps us in these scenarios where we are trying to locate missing objects. We're getting even inspired by how animals navigate in this environment.
The question of where you are in the ocean is big, hard, and very important. And it's really, really easy for most animals. Fish do not get lost. There are fish like bluefin tuna that will cross half the planet and turn around and go home again, which is really, really impressive. And the question is, how do they do that? One possible answer is they look up at the sky and it tells them where they are.
Most of this, the data that we know about the water comes from satellites, miles, 20 miles, 30 miles above from the sky. Developing a bio-inspired technology that can help us uncover the mysteries of the ocean, I think it's a very interesting problem.